Hello, and in our previous segments, we have now learned about this planet that is elsewhere in our galaxy. We know how long it takes to go around its star. We know its distance from its star. We know the mass of the planet. We know the radius of the planet. We know the density of the planet. And so now we want to see if we can figure out its composition, what it's made of, and then also what's its temperature like. And in order to do this, we're going to take a diffraction grating and we're going to put it on our telescope and we're going to look at the spectrum of the light given off by the planet. So previously, we took a diffraction grating and we put it on our telescope and we measured the spectrum of the star, so the light given off by the star. Now we're going to measure the light given off by the planet. And so we should have learned in a previous lesson that every element in the periodic table has a unique emission spectrum. So it gives off a unique set of colors. Hydrogen is going to be different than helium. Helium is going to be different than carbon. So that if we look at the different colors given off by the spectrum of this planet, we should be able to figure out what is the atmosphere like on this planet. What's it composed of? Does it have oxygen in its atmosphere, or is it mainly just composed of hydrogen and helium? So if it was composed of hydrogen and helium, what kind of a planet do you think it would be? It would be like Jupiter. On the other hand, if it had oxygen in its atmosphere, what would that be like? That would be like the Earth. So that's what we're really looking for. So if we find a planet that does have oxygen in its atmosphere, that's a good indicator that it would be able to support human life. All right, the next thing that we're going to look for, though, is which color in the spectrum is the brightest. That's going to tell us our maximum wavelength. So we talked about black body spectrums and how they would have a hump like that, and then whatever wavelength would correspond to where it has its maximum, we call that lambda maximum. And then we had a formula called Ven's law that we could plug the wavelength into, and then it would tell us the temperature of that particular black body. So now we'll know the temperature of the atmosphere of that planet based on the maximum color of light emitted by that particular planet. So that is pretty amazing that we can measure all of these different properties of a planet. So here's our summary. Summary of properties of a star and its planet that can be measured. So you've got the period of the planet, the distance between the planet and the sun, the mass of the planet, the radius of the planet, the density of the planet, temperature of the planet, and the elements in the planet's atmosphere. So in our next segment, we are going to talk about properties that we have actually observed in planets in our galaxy.